Hi students, welcome back to our channel Smarter Everyday Over Learning. Dear students, we have been learning the topics from the chapter Organic Chemistry, some basic principles and techniques from grade 11 NCERT. Today in this session, we are going to learn about the topic Isomerism. Okay, Isomerism, it is a very important topic of you and what you have studied in your previous 10th standard. Also the isomerism topic, you studied about that. Okay, just we can recall what is meant by isomerism and students what is the definition and in which purpose we have to use this isomerism. Okay, let's see the definition of this. See here, for suppose two or more compounds having the same molecular formula. Here students, you need to identify that same molecular formula but different chemical and physical properties. The compound must varies their physical and chemical properties and those must have the same molecular formula. That type of properties of compounds are called as isomers, and this type of complete phenomenon, entire phenomenon is known as isomerism. Okay students, now let's see the example of, see in this example CH3, CH2, CH2, CH3. So this is entirely C4H10. Okay, and here how many carbon atoms and hydrogen atoms you have to observe in this structure, and you can write the condensed molecular formula for this structure. Dear students, this is called as, here 1 2 3 4 carbon atoms are presented, so the root word should be but, then all the single bonds only presented here, then students it belongs to alkane group, that is a saturated compound. Here the name is butane. Okay, the same butane, and here I am going to write CH, here CH3, again CH3. So if you count these atoms also, 1 2 3 4 C4, 4 carbons just like this only, and hydrogen should be 3 3 3 9 plus 1 10, so H10. This is also C4H10, this is also C4H10 just like butane, but here students methyl group is located. If you count these carbon atoms 1 2 3, so 3 is the root word here, then students the name should be probe here. So here if you count 2 methyl, at the second carbon methyl group is located, so 2 methyl propane is the word of this compound, and students it is also called as isobutane. Okay, 2 methyl propane and isobutane, these two are same. This is about the isomerism property. Here in the first one is, this is called as butane, or the common system is known as N-butane. We should represent like this also, N-butane. In the second one is called as 2-methyl propane. Here it is also called as isobutane in the common system. Okay, we find both of these compounds in nature, they have different properties due to the different in their structures. Compounds of this type of which are having the same molecular formula but different properties is known as, that compound is called as isomer. So these are all compounds are called as isomers, but students here the entire property is known as isomerism. What I told you previously is as the definition. Okay, and here students one more important thing, what is meant by this iso. For this word a particular meaning is there, that is known as, here iso means same, and meros means part. Okay, that is they have same molecular formula. In these above examples what we discussed, isomerism is due to the difference in the structures, therefore it is called as structural isomerism. Let's see some more types of this isomerism. Here you have to see isomerism types, structural isomerism and stereoisomerism. There are two types, two categories are there, and here students again in the structural isomerism you are going to have 6 types here. 6 types. The first one is chain or nuclear isomerism, position isomerism, functional isomerism, and the fourth one is metamerism, and fifth one is tatomerism, and number 6th is ring or chain isomerism. Okay students, in these types again in the functional isomerism, again we are In this third type, functional isomerism, in this some subtopics are there. You are going to learn about these 9 subtopics about alcohols and ethers and carboxylic acids and esters, aldehydes, ketones, aromatic alcohols and phenols and ethers. Here dienes, allenes and alkynes, nitroalkanes, alkyl nitriles and amino acids, and primary, secondary, tertiary amines, and cyanides and isocyanides, amides and oximes. Okay students, these are the nine categories you are going to learn about this functional isomerism. Okay, let's start about this structural isomerism. What is meant by structural isomerism and what are its types, and what about stereoisomerism? If you study about all of these, and then that's the topic is isomerism will be completed, right? Structural isomerism, the compounds which are having the same molecular formula should be same and different structures. Their structures should be different. They are having different structures, that is different arrangement of the atoms within the molecule are called structural isomers, and the phenomenon is called structural isomerism. Okay, the arrangement of the atoms like this, the arrangement of the atoms within the molecule. This is a molecule. Group of atoms is known as molecule, right? So this is a molecule here. Then this is called as structural isomers. Okay, different arrangement of atoms within the molecule is called as structural isomers, and the phenomenon is known as structural isomerism. Okay, it is of all the following 6 types, as I told you previously. These are the types here up to 6th one, ring and chain isomerism. Let's see the first type here, number 1, chain or nuclear isomerism. In this first category, the compounds which are having same molecular formula is same but different arrangement of carbon chain within the molecule. Okay, these are called chain or nuclear isomers, and this complete phenomenon is known as chain or nuclear isomerism. For example, butane means CH3 CH2 CH2 CH3. Here 4 carbon atoms, so this is called as butane, and students we can also call it as N-butane. Okay, and for suppose from this CH3 CH, here one CH3, here one methyl group. Okay, and here if you want to give numbering to these carbon atoms 1, 2, 3, so this is called as, here are the 3 carbon atoms, that's why the root word should be prop here. Then all the single bonds are presented here students, that is only N is the secondary suffix here. Okay, and now at the second carbon methyl group is located, so that you need to add here 2-methyl propane. Similarly, you have to observe here students N-pentane and isopentane. I'm going to draw the structure of pentane here. From this N-pentane, here 5 carbon atoms and all the single bonds, so this is called as pentane. From this, like this, I have drawn the structure 1, 2, 3, 4 carbons. Then students, the name should be but. Then all the single bonds means butane here. Then at the second carbon methyl group is located, so 2-methyl butane, and this is also called as isopentane. According to isomerism property, isopentane and the 2-methyl butane, these two are same. Okay, this is the example of chain or nuclear type of isomerism. Let's see the second one, position isomerism. For suppose if you have the compound which are having same structure of the carbon chain, and they can differ only in the position of the multiple bond, nothing but triple bond or double bond here. These are the multiple bonds, or the functional group are called as position isomers, and this phenomenon is known as position isomerism. Then if you see the examples, then you can understand very clearly. For example, here the compound what I have here, this is 1, 2, 3, 4 carbon atom. In this example, 4 carbon atoms are presented here, then the root word should be but. And students, here is the double bond. When you want to give numbering to these carbons, you have to give first priority to this carbon. Then students, 1, 2, 3, 4, like that. But here, basing upon this double bond, you should say that 1 in. Why? Because at this first carbon only double bond is located, so the name should be like this. And in that such a way, here see, same 4 carbons presented here, but is the root word. And students, at this second carbon, so 1, 2, 3, 4, at this second carbon double bond is located, so but2ene. So students, if you see here, the position of these bonds, these are the multiple bonds, the position is different. So the same structure they have, structure is same, but they are differ only in their position of the multiple bonds, that is known as position isomerism. Like that only, if you see here one example, similarly this is 1, 2, 3, here is the alcoholic group. You have to give first priority to this alcoholic group while you are giving numbering. So 3 carbons means the root word is prop here, prop. So at this first carbon alcoholic group is located, then propanol, so the name is propanol. And here same students, see at this second carbon 1, 2, 3, like this, same structure, then propanol 2-ol. Okay, this is also same the examples of position isomerism, right? This is about second type. Let's see the third type. What we have, functional isomerism. Dear students, here you have to face a major task. About these 9 types you are going to study in this functional isomerism. I'll try to give you a clear-cut idea. Briefly, I'm going to explain to you about these 9 structures. In this type of isomerism, the molecules which are compounds having the same molecular formula but different functional groups are called as functional isomers. This complete entire phenomenon is known as functional isomerism. Okay students, many classes of organic compounds show functional isomerism among themselves. Okay, in that the first type is alcohols and ethers. Okay students, this is the first type. Here the common general formula is CnH2n plus 2 and O. Okay, this show the functional isomerism. For example, the molecular formula of C2H6O represents the following 2 functional isomers. Here C2H6, then if I draw the structure for this CH3 CH2OH. Okay, C carbons are 2 here, then hydrogen 6 here, 1 O is there. This is called as, this is OH means alcoholic group, then the suffix is OL, then 2 carbons means ethane, then students ethanol, nothing but ethyl alcohol is the formula. Then if I write the next example here, CH3OCH3. Okay, then here this is the structure of either main RO R dash, this is the main structure for ethers. Then this is called as dimethyl ether and the name is methoxymethane. Okay, and this is about the functional isomerism, the first type, alcohols and ethers. Now let's see about second type. What we have here, second type is carboxylic acids and esters. Here the general formula, what we have, CnH2nO2. Okay, this general example, general formula show the functional isomerism. For example, C2H4O2. According to this, C2H4O2 represents the structure should be CH3 C double bond O OH. Okay, this is called as ethanoic acid. Ethanoic acid, nothing but CH3COOH means, you know very well, acetic acid. acetic acid, right? And the next structure, if you have to see here, C double bond O, OCH3, and this is called as methyl formate or methyl methanoate. Methyl formate. Okay, this is about carboxylic acids and esters which are showing the functional isomerism. We shall go for third one. What we have, third type, aldehydes, ketones, unsaturated alcohols and unsaturated ethers. Okay, the general formula I'm going to write here, CnH2nO. This general formula show the functional isomerism. For example, C3H6O. According to this structure, this molecular formula represents the structure CH3 C double bond O CH3. Okay, this is called as, here if you want to count the carbon atoms here, 1 2 3. So students, prop is the root word. This is the ketonic group, so propanone is the word. Propanone is the word. And see the next example, CH3 CH2 C double bond O H. Okay, like this. The name should be here CHO, aldehyde group this is. So the root word is prop. Then students, propanol is the IUPAC name of this. Why? Because this is the aldehyde group. See in this example, here also 3 carbon atoms, 1 2 3. So the root word is prop here. At the second carbon, 1 2 3, at this second carbon the double bond is located, so 2E. The numbering should be like this. Okay, why? Because this is the alcoholic group, you should give first priority to this group, so the numbering should be from like this, 1 ol. The name is like this. Okay students, this is about the third type, the aldehydes and ketone, unsaturated alcohols and unsaturated ethers. Okay, this is about the examples and everything. Now let's go for fourth one here, aromatic alcohols, phenols and ethers. Okay, this shows the functional isomerism. For example, C7H8O. Okay, represents the following structures. These I'm going to draw here. This is the benzene structure, and to the benzene structure CH2OH is located, that is known as benzyl alcohol, and for suppose OCH3 is located, that is known as anisole. Okay, and again to this benzene ring only, at first carbon OH group, at second carbon CH3 methyl group is located. This is called as ardocresol. This is the ardo position, ardocresol. Okay, then basing upon this structure in such a way, to this benzene OH group and CH3 methyl group is located here at the bottom of the ring. This is called as metacresol. Metacresol, such a way. In this way only, for suppose this is a benzene ring students here, and here one methyl group, here one hydroxyl group is located. This is called as paracresol. Okay, the isomers of this structure of ardocresol and metacresol and here paracresol, these may also be regarded as position of isomers here. Position isomers. Right, this is about fourth one. Let's see number 5. Dienes, allenes and alkynes. Okay, the general formula what you have, CnH2n minus 2. Show the functional isomerism. For example students, C4H6. According to this general formula C4H6, you have to represent that CH2 double bond CH, CH double bond CH2. Here 4 carbon atoms are presented. Then students, the root word should be buta. But is the root word, and here 2 double bonds are located, but 1 2 3 4 at the first carbon and the third carbon, 1 and 3 2 times double bonds are located, then diene. You should represent like this. Okay. And now the next structure I'm going to draw here, CH2, double bond C, double bond CH, CH3. See this structure, this is also, the root word is but, then buta. And while giving numbering to this, from left to right, like this only, if you give numbering 1, 2, 3, 4, then students, the name should be at the first carbon, second carbon, 2 double bonds are located, then 1, 2 diene. Okay, then you shall see the next example here, CH3, CH2, C, triple bond CH. Then to this triple bond you have to give first priority while giving numbering to this compound. Here also 4 carbons, then but. 1 ine is the name of this compound. Okay, for suppose in the triple bond is located like this, CH3C, triple bond C, again CH3, like this. Then what you have to do, the same but is the root word at the second carbon, 1, 2, 3, 4, at this second carbon triple bond is located, so 2-ine is the IUPAC name of this compound. This is about dienes, allenes, alkynes. Okay, number 5. Now students, number 6, you have nitroalkanes, alkyl nitriles and amino acids. CnH2n plus 1 NO2. This the general formula, shows the functional isomerism. For example, students, C2H5 NO2. This is the structure, represents this functional isomerism. How we can see here, for suppose CH3 CH2 N double bond O, just like NO2. Okay, this is called as, this is ethane, so nitroethane, the name should be like this. And if you see the next example, CH3 CH2 O N double bond O, like this. This is called as ethyl nitrite. And here NH2 CH2 C double bond O, again OH. This is called as ethanoic acid. Oic acid is the suffix. Here COOH is the carboxylic group. Okay, this is about number 6, nitroalkanes and alkyl nitriles. Now let's see number 7, types of, all types of amine, students, primary, secondary, tertiary amines. Okay, best example here, C3H9N. This is the formula, represents that functional isomerism. How we can see, NH2 is the amine group here, 3 carbon atoms, then the name should be, prop is the root word here, propane, 1 amine. Okay, this is primary amine. Okay, primary amine. And if you see the next example here, what I have written, right here, CH3 CNH. NH means here the removal of 2 hydrogens takes place, then this is known as N-methylethanamine. This is the secondary amine. Okay, and if you see this here, third one, here removal of 3 hydrogens takes place and methyl group, the name should be N-dimethylmethanamine. Okay, this is only tertiary amine. Okay, this is about the 7th type, what we have, primary, secondary and tertiary amines. Okay students, now we shall go for 8th one, number 8. Number 8, what we have, cyanides and isocyanides. Here is the general formula, CnH2n minus 1 N. Okay, this shows the functional isomerism. For example, students, say C2H3N. Okay, the structure should be CH3 C triple bond N. This is known as, and another formula also I am going to write here, CH3N, like this. The 2 names should be ethane nitrile and the next one is methyl isocyanide. Okay, these are the names of these 2 compounds. This is about cyanides and isocyanides. We shall go for 9th one. This is the last one, amides and oximes. Here, after functional isomerism, the third one, we are going to learn about metamerism and tatomerism and ring and chain isomerism. If you learn about these three, then today's topic will be finished about isomerism. Now let's see about the last ninth one from functional isomerism. Amides and oximes. Here the general formula CnH2n plus 1 NO. Okay, these show the functional isomerism. For example, C3H7 NO according to this general formula represents the structure CH3 CH2 propanamide. Here is the propanamide, and here next structure you have CH3 CH2 CH double bond and OH. This is called as propanol oxime. Oxime formula, this is propanol oxime. This is about the third type. 9 categories we studied about this, and students, the next one is fourth one, metamerism. Okay, here is the definition you have to see. Compounds having the same molecular formula but different number of carbon atoms. Carbon atoms are also called as nothing but alkyl groups on either side of the functional group, that is just like this side of the functional group, just like this, and NH and CO. Okay, and these are called metamers, and the phenomenon is called metamerism. Metamerism occurs among the members of the same homologous family. For example, students, homologous series, you know that. Here one methoxy group is located at the first carbon, so 1, 2, 3. 1 methoxy propane. Prop is the root word. Like that only in this example, 2 methoxy propane. Okay, 2 methoxy propane. This is about the metamerism. Next we shall go for number 5, tatomerism. It's a special kind of functional isomerism in which the isomers exist in dynamic equilibrium with each other. It arises due to the migration of hydrogen atom from one polyvalent atom to the other within the same molecule with necessary rearrangement of linkages. Rearrangement of linkages takes place here. The isomers thus obtained are called tatomers, and this complete phenomenon is called as tatomerism. Here students, tatomerism is also called as, here a new word has come, desmotropism. Basing upon desmos means bonds, types of bonds, and propos means turn. Basing upon these two words, the name should be desmotropism. Tatomerism is also called as desmotropism. Okay, here students, there are two types. Tatomerism is of several types we are going to see here. First one is dyad system, and the second one is triad system. Okay, let's see one by one about this dyad system. This type of tatomerism involves at 1-2 migration of a proton from one polyvalent atom to the another within the same molecule with necessary rearrangement of linkages. For example, here you can see here from HCN, NC. Okay, this is hydrogen cyanide and hydrogen isocyanide. Here hydrogen migrates from carbon to nitrogen, like this, carbon to nitrogen. The alkyl derivatives of these tatomers are called cyanides. Here is the RC triple bond N, this is alkyl cyanide, and students, RN double bond C, this is the second type, that is alkyl isocyanide. Okay, this is about dyad system, and it may however be noted that although hydrogen cyanides, hydrogen isocyanide are also these tatomers, alkyl cyanides and alkyl isocyanides, these are all not tatomers but are simply functional isomers. These two are. Now let's see for triad system. Triad system. There are many types of triad systems. In all these systems, hydrogen migrates from one polyvalent atom to the third polyvalent atom within the same molecule. Here students, ketonal Ketoenol Tatomerism is just one type of triad system. In this type of tatomerism, one form tatomer contains the keto group just like this, while the other contains the enolic group just like double bond COH. This is the enolic group. Two simplest examples of ketoenol tatomerism are acetaldehyde and acetone. Right, and we shall go for examples from acetaldehyde and vinyl alcohol, nothing but enolic form. This is the negligible amount, okay, and to this, if you give numbering to this carbon 1 2, and this is the example. From these two examples, cyclohexanone and cyclohex-1-ene 1-ol. Okay students, from these are all examples. In these examples, monocarbonyl compounds listed above, these are the examples. The greater stability of keto form with respect to the enol form is due to the greater strength of the carbon and oxygen pi bond. Okay, and the last one is ring chain isomerism. Compounds having the same molecular formula should be same, but possessing open chain and cyclic structures are called ring chain isomers, and this phenomenon is known as ring chain isomerism. For example students, here the first one, A, alkenes and cycloalkanes, CnH2n. Here is the example, C3H6 represents that CH3CH double bond CH2, and this is the cyclopropane, okay, which are ring chain isomers. Here students, C4H8 represents like this. This is the first type, C3H6, and now the second type is CH3 CH2 CH double bond CH2, and the structure should be like this. Cyclobutane, this is also called as but1-ene. At the first carbon, double bond is located, or this is also represent like this. Here is CH3, here one hydrogen, methyl cyclopropane, which are here ring chain isomers. Similarly, but2-ene, next example, but2-ene or 2-methyl prop1-ene. These two are the ring chain isomers of cyclobutane and methyl cyclopropane, and this is about A. And now see about B. Alkynes and cycloalkenes, here the general formula CnH2n-2. Here students, C3H4 represents the structure of CH3 C triple bond CH. This is called as propyne, and the same you can draw, this is cyclopropene, which are also ring chain isomers. Cyclopropene, this is about B. And now let's see about the C1, unsaturated alcohols and cyclic ethers. The general formula CnH2nO. Okay, then students, C3H6O represents the structure. Here is the structure, prop2-ene 1-ol. This is the alcoholic group, and here is the next one, oxetane. Okay, this is about the sixth one, ring chain isomerism. Okay students, now the last one is about stereoisomerism. Once you can check the mind mapping what I have drawn at the starting. This is about metamerism and tatomerism is completed, ring chain isomerism completed students, and here the starting isomerism types we are discussing now. Structural isomerism is completed up to now. Now students, about stereoisomerism, let's say briefly. Stereoisomerism, isomers which have the same structural formula but students in their different relative arrangement of atoms or groups in space. is called stereoisomers. This complete phenomenon is called as stereoisomerism. In Greek language, stereo means space and meros means part. Okay, and these are types, students. You can see cis and trans. Isomerism is the example of stereoisomerism. Here you can see C double bond C. Here one CH3, here H. Here also same CH3, here also H. This is called as cis-but-2-ene. If you see these two structures here, this name is cis-but-2-ene and this is trans-but-2-ene. Okay, if you see here CH3 and H, here the reverse composition you can see H and CH3. Due to pi bonding between the two carbon atoms, the rotation around the carbon double bond, here is the rotation, is prohibited, and hence the geometry of the atoms or groups attached to the carbon atoms get fixed in shape. That is why this type of stereoisomerism is also called as geometrical stereoisomerism. And other types of stereoisomerism or optical geometrical isomerism, okay, again some types will be there. You will learn about them in our next session. Again we have come back to this mind mapping what we have discussed previously at the starting of this class about isomerism. Here isomerism definition completed and two types, main types are completed: structural isomerism, stereoisomerism. Okay students, this is about our today's session, and if you understand this class, your opinion and your doubts also you can convey in the comment section. Please subscribe to my channel for my further updates. Thank you so much. Thanks for watching.